So this is a very interesting problem, and this problem is called the petrol filling problem, or sometimes it's also called as the circular gas station problem. Because in some parts of the world like the US, a petrol or a diesel filling station or a petrol pump in Britain and all of Britain's colonies, or erstwhile colonies, I should call them erstwhile colonies, like India, Sri Lanka, South Africa, they're called as petrol pumps, right? In the US, they're called as gas stations. Whatever the name of the problem is as follows. It's called the circular gas station problem or the circular petrol pump problem. And the problem is as follows, right? Imagine each of these squares represents a petrol pump or a gas station, and the number inside this represents the number of liters of petrol that I have, right? Let's assume this is the number of liters of petrol that I have. So this gas station has 1 liter of petrol. This has 2 liters, this has 3 liters, 4 liters, and 5 liters. And this arc, the number 3 here represents that to travel from this petrol pump to this petrol pump, the distance here is 3 kilometers. And let's assume that to travel 1 kilometer, I need 1 liter of petrol. Okay, let's assume that simply. Okay, so as to make the problem easier. So the challenge here again, so what is given to me is basically an array like this of petrol capacity in each of the pumps and the distance to the next petrol pump. I'm given these two arrays literally, right? So 1, 2, 3, 4, 5. This is the capacity in each of the petrol pumps. There's a capacity in the 0th pump, first pump, second pump, third pump, and fourth pump. And the distance from the 0th pump to the first pump is 3. The distance from the second pump to the third pump, or from the first pump to the second pump, is 4, and so on and so forth. Now, again, here we are making an assumption that to travel 1 kilometer, we need 1 liter. Okay, that's a simplifying assumption here. Now, what we want to do here is we want to start from any petrol pump. We can start from any petrol pump. Suppose, let's assume I want to start from this petrol pump. I can start from any petrol pump here. I want to ensure that, so when I start here, my petrol tank is empty, or my gas tank is empty in my car. So I can fuel up this whole of this, whatever is the capacity here, I can fill it in my car, right? Let's assume my car has unlimited amount of capacity, theoretically. Okay, so I can fuel up this whole 2 liters of petrol in my car, and then I can start traveling. But with these 2 liters, I can only travel 2 kilometers, but the distance is 4 kilometers, which means I'll stop somewhere in between, right? So that is a problem here, right? So what I want to do here is this. I want to answer this question. Is there a petrol pump? Is there a pump, or is there a gas station that I can start from, that we can start from and complete this tour? I want to complete this whole circle, right? Is there a pump that we can start from and complete the tour and basically complete this whole tour, right? Why is it's also called as a petrol tour problem, or a gas station tour problem, because I want to start from one station like this and finish all the other stations and come back to this. And is that even possible? First, that's a question. Is there a pump that we can start from such that I can finish the tour without getting stuck anywhere, without being stuck, right? So this is the first part of the question. If there exists such a pump, what is that pump? That's the second part of the question. Now, there is a brute force solution to this problem, right? So again, think about it. I want you to pause this video here. I hope you understood the problem here, right? So I can start from any pump. Like, for example, let me show you an example. Let's assume I start from this pump. My petrol in the car, or gas in the car, is empty. So I fuel up 2 liters, and with these 2 liters, I can travel 2 kilometers. Which means I start traveling, halfway I get stuck, which means I can't start a tour from here. Now, can I start a tour from here? Let's see if I can start a tour from here. Let's see, can I start a tour from here? If I start from here, I fuel up 1 liter, but the distance here is 3 liters, which means as soon as I travel 1/3 the route, my petrol in the car is empty, right? My petrol tank, or the gas in my car, is completely exhausted, right? Now, what if I start from here? So instead of this, so look at this, okay, let me just erase this. So instead of this, can I have a tour that starts from here? let's see. So I fuel up 4 liters. I consume 1 liter. So by the time I come here, I have 3 liters. I again fuel this up. Now I have 8 liters. I take all of this fuel, right? So I have 8 liters in my tank. 8 minus 2. By the time I reach here, I have 6 liters. So 6 plus 1, now I have 7 liters, right? So 7 minus 3, I'll have 4 liters by the time I come here. 4 plus 2, 6 liters here, right? 6 minus 4, look at this, 6 minus 4, I have 2 liters by the time I come here. Now I'll again fuel up. 2 plus 3, I have 5 liters, so I can again come here. So if I start my tour from here, I can actually complete successfully, right? Now I want to find a pump from which I can start my tour and successfully complete, right? That's the challenge here. Now again, since you've seen this example, right? Since you've seen this example, let's try to tackle this. Okay. So since you've understood this problem, pause this here and think of a simple solution first. It's always important that you first think of a simple solution, then we'll optimize the solution later. So please pause it here and think about it. If you come up with a decent solution, please write the code for it and make it work. Okay. So I'm assuming now that you have thought through some simple solution. One very simple solution is called the brute force solution. One very simple solution is the brute force solution. The brute force solution, what I'll try is this. Again, this is my 0th petrol tank, right? So I'll try to start a tour from here and I'll see whether I'm successful or not. So here, when I start from here, I can't even go to the next pump. So this can't be my starting point. Next, I try to start from here, right? Again, I try to go through all these vertices or all these petrol pumps and see if I can finish the tour. If I cannot finish it, I'll say I can't. Then I'll try this. Then I'll try this and so on and so forth. So look at this. For every petrol pump, so I'm trying to consider every petrol pump as the starting petrol pump of my tour and try out all the possibilities. So for every petrol pump, because see, there are n petrol pumps I'll try to use as starting petrol pumps. And for any petrol pump that I'm using as a starting, as my starting spot, right? I might have to look at all the other petrol pumps. I might have to travel this whole thing to decide whether this is a valid starting point or not, right? So in total, if I apply this brute force solution, my time complexity is order of n square, because I'm trying to consider every petrol station as a potential starting point. And when I consider any petrol station as a potential starting point, I might have to do the whole tour, right? And then finally decide that, okay, this is not working, so I have to try again, right? In the worst case, again, this is the worst case time complexity. In the worst case, my time complexity could be order of n square. This is a brute force solution, a simple solution nonetheless, fairly decent. Now here comes the interesting part. If you're here for an interview, I would say this is a decent first cut solution, very good. Now, can you improve this solution? Can you improve this solution for me? The hint that I'll provide you here is, can you build an order of n time complexity solution? This is my hint. My hint here is, can you think of an order of n solution for this? You've come up with an order of n square worst case time complexity solution. Very good. Can you come up with an order of n time complexity solution? That's my hint. Now here again, try to pause this video and try to think of an order of n solution. And one interesting observation here is, if you want an order of n solution, which means the moment you visit a petrol pump, you should not visit it again, right? You should try to avoid visiting it again. Okay, that's one strategy of building order of n time algorithms. Okay, so here I'm assuming that you have thought through this, you have thought through a way, or you have not been able to come up with it. If you have been able to come up with an order of n time algorithm, please go ahead and implement it. Otherwise, let's look at the solution. Let me redraw this diagram here. Okay, so now here I'll try to explain you how to think about this problem and how to arrive at a solution. There is no point in me just to tell you the solution, because if I tell you the solution, you don't learn how to think. I want you to learn how to think. That is very, very important. Okay, so these are all my petrol pumps. Let's also write down the distances here. 3, 4, okay, so 3, 4, 5, 1 and 2. Okay, so let's start with see again, in my array, I'm given this order, right, of petrol pumps. I'm given this order for my distances also. So I'll start with the very first listed petrol pump, right? So 1 second, sorry. So I'll start here. Okay, I'll start here. Now when I'm starting here, I'll create two variables. The first variable is called as surplus, which means how much extra do I have. The second variable, I'll call it deficit. How much fuel am I lacking? Okay. These variables are also called as a sum and difference variable. But the right way to think about them is surplus, which means how much extra petrol do I have or how much deficit petrol do I have. This is one way to think about it. Again, let's tackle this problem. Imagine if I start here, right? So my starting, I'll try to start from the very first petrol pump that is given to me, right? So I'll fuel up. Now I'll see, with this fuel, can I travel this distance, right? With this fuel, can I travel this distance? So what is my starting node? This is my starting node now. I'll see if I can travel this distance. I can't travel this distance. Because I can only fuel 1 liter of petrol, but the distance to be traveled is 3 kilometers. I can't travel. But now, which means this can't be my starting point. So I'll arrive here. But when I arrive here, I want to store this information that I have. There is a lesson that I learned here, right? That the amount of petrol that is here is less than the distance that I can travel. By how much? I want to store that value here. So what I'll do here is in my deficit. So till whatever I have seen till now, whatever nodes that I have seen till now, or whatever petrol pumps I have seen till now, what is the deficit now? This is 1, this is 3. So this is the data that I have already seen. I have seen this node already, right? And this node can't be the starting node. We have decided that this node can't be the starting node. But to travel from here to here, I need 2 liters extra by the time I arrive here. Otherwise, I can't travel this distance. So to travel from here to here, there is a deficit. So in this petrol pump, there is a deficit of -2. So I'm trying to store that information here. Now I'll again make my surplus, because then this can't be the starting point. Now I'll try to consider this as a starting point. If this is a starting point, how much fuel do I have at starting point? 0, right? So now I'll see if I can start, if I start here, right, with 0 fuel. Again, this is just additional information to keep track of what we have already learned. Right? I don't want to dump the information that we have learned by trying to use this as a starting node, that this has 2 liters deficit than the distance that we have to travel. I'm trying to keep that information handy. Okay, so that again, this information will help me evaluate if there is even a solution or not. Okay, we'll see how it is useful. Now I come here. Now I try to consider this as my starting point. Okay, so if I try to consider this as my starting point, what happens now? Now I don't have any surplus. If this is my starting point, my surplus equals to 0. I don't have any fuel to start with. Now I have 2 liters of fuel here. I have to travel 4 kilometers with it. I can't do that, which means this can't again be the starting node. Now I'll try to consider this as my starting node. But there is a lesson that I've learned, that here also there is a deficit of 2 liters. So I'll try to use this. So I'll keep incrementing my deficit or difference, right? So I have -2 till here. Again, I have -2 till here, which means of all the petrol pumps I've seen, from the 0th petrol pump to this petrol pump, there is 4 liters of deficit that is there in the petrol pumps, which means by the time I arrive here, I need 4 liters extra petrol to be able to finish this whole loop, right? That's a problem that I have now, right? Now let's see. Now let's continue this circle. Since again, I'm trying to consider this as my starting point. At the very beginning, how much surplus do I have? Again, this can't be my starting. This can't be my starting, right? Now, if this is my starting, at starting, how much surplus do I have? I don't have any surplus. My tank is empty, right? My fuel tank is literally empty now. Now, if my fuel tank is empty, now what will I do here? Look at this. Now, I can fuel 3 liters of petrol here. With 3 liters of petrol, I have to travel 5 liters here. I have to travel, 5 kilometers. That is also not possible. That is also not possible, right? So again, which means this also can't be my starting node. Okay, now I'll try to consider this as my starting node. Again, this can't be my starting node, right? Because I have to travel 5 kilometers here just using 3 liters of fuel. I don't have that, right? So now again, I'll keep my deficit. I'll keep incrementing my deficit. What is the deficit here? Again, 2 more liters. So my deficit has become -6, right? So I have -4 already, and then to -4, I'll add 3 minus 5, which is -2. So I get -6. So now I'll consider this as my starting node. Look at this. I've ruled out the possibility that this can be my starting node. I've ruled out this. I've ruled this out. Now, can this be my starting node? Let's see. Again, there are cases wherein there may not be any starting pump, where if I start, I can complete a tour successfully. We have to be able to answer that also. So now let's see what happens if we are here, right? So my deficit is -6, my surplus is 0 because I'm starting again here. Now here, if I fuel up 4 liters, to travel this distance, I only will consume, look at this, I only will consume 1 liter here, which means by the time I arrive here, there is still a surplus of 3 liters in my petrol pump, right? In my gas tank, in the car, or the petrol tank of my car, I have 3 liters of extra petrol because I have fueled up 4 liters. I've only consumed 1 liter to cover 1 kilometer here. So, which means by the time I arrive here, I have this surplus. And to travel here, there is no deficit. I'm not adding any deficit. My deficit still stays the same. Because I have surplus here, I don't have to worry about deficit, right? This deficit will not be will not change now because I have surplus here, right? Now again, let's go from here to here. Okay, so I've arrived here. Okay, very good. So which means this can still be my starting node. Okay, at least this first hop it has done successfully. Let's look at the next hop. Okay, let me change the color slightly. Okay, so this is the surplus that I have, and this is the deficit I have by the time I come here. Now look at this. Now from here, now I can fuel up 5 liters here. Look at this. I can fuel up 5 liters, which means by the time I arrive back here, so what is my total gas tank? What is the petrol pump now? 3 plus 5 is 8. I have 8 liters of petrol here, and I'm going to consume 2 liters here, which means I'll arrive here with 6 liters of petrol. And there is no deficit here, right? There is surplus here. My surplus changed. My deficit by the time I come here is -6. Look at this. I've touched all the points now. And since I started here and I kept counting surplus, I kept counting deficit. Look at this. I started here and I kept counting the deficit from this place. By the time I arrive here, look at this. By the time I arrive back here, I have 6 liters in my gas tank and there is a deficit of 6 liters in this part, right? Now the 6 liters extra that I have will compensate this deficit that I have, right? Again, when these two are same, when I add these two, look at this. If I add S plus D, if it is greater than equal to 0, with this amount of fuel that I have here, I can traverse the rest of the cycle. Even though I started here, look at this. I did not test. I do not have to test the whole thing again, right? Because I'm keeping track of the deficit in my petrol pumps. I'm tracking this information. This is very important information. So by the time I traverse through all the elements, I have a surplus of 6 liters in my gas tank or in my petrol tank. And in this path, there is a deficit of -6. Of course, these two will tally out. As long as my S plus D is greater than 0, I can cover this distance. But what if your S plus D is less than 0? Imagine if my surplus was 5. Imagine a case. And my deficit is -6. If that's the case by the time I arrive here, then I can't complete the tour. Which means if my S plus D is less than 0, there is no tour that can solve this problem. Right? And this is a very, very important idea. Again, the key idea here, again, this algorithm is order of n. Because I'm visiting each petrol station exactly once. The key idea here is to keep track of both surplus and deficit. How much extra petrol will I have through my journey, and how much is the lack of petrol in this path across these petrol stations. If I just keep track of them, I can create an order of n algorithm. That is the key insight here. Okay. And now once you have this insight, code is straightforward. This problem is not about code. This problem is mostly about coming up with this idea that I can keep track of surplus and deficit. Right? What is surplus? Surplus is the amount of petrol that I have in my petrol tank. Deficit is the amount, is the lack of petrol to cover some lengths in the petrol stations. Okay. Instead of calling them surplus and deficit because they're slightly complex words, we will just call them as sum and diff. Right? Or S and D. You can call them whatever you want. I hope you understood the logic here. Again, try it with other examples also. This is the key observation. And this observation you can only arrive at by working out examples. when you're given an algorithms problem like this, where coming up with the solution is coming up with the idea on how to tackle this is important, the best way is to take an example. Best way is to take an example and understand what's happening while solving this example on a pen and paper. So when you obtain this idea, when you make this observation that I can keep track of both surplus and deficit, code is straightforward. Actually, this code is literally 10-15 lines of code. Look at this. What am I doing here? I'm given an array of petrol. I'm given an array of petrol capacities. I'm given an array of distances and the number of petrol stations. I'm creating my sum equals to 0. Sum is nothing but surplus. This is my starting petrol station index. My difference is nothing but my deficit. Look at this for loop. It's just a simple for loop here. For I equals to 0, I less than n. Sum equals to sum plus how much petrol minus distance. Right? See, sum initially is 0. After traveling the ith, so after filling up using the petrol in the ith station and traveling distance I, how much surplus is there? That's what I'm storing in sum here. Now, if sum is less than 0, that means I can't travel. So I'm changing my starting node to I plus 1. I'm also updating my diff. See, the very fact that sum is less than equal to 0 means there is a deficit, which means I need to update my variable diff, which is storing the deficits. And I make my sum equals to 0 to make the I plus 1th node, as a starting node. This is what my for loop does. And finally, I'll check this. If sum plus diff is greater than 0, then whatever is my starting node right now will be the answer, or else it will be minus 1. And minus 1 basically implies that there is no way to complete this tour, which is basically like this. We have discussed this case, right? Sum plus diff greater than equal to 0 basically means there is a solution. Sum plus diff less than, or surplus plus deficit less than 0 basically means there is no way to complete the tour here. Again, this code itself is very, very simple. Again, by looking at this code, you can easily understand that this is an order of n algorithm because there is a simple for loop here, no recursion, nothing very fancy. The key idea here is these two variables, creating a surplus variable and a deficit variable and working through it. Again, the most important part of problems like this is to actually work out an example and try to understand what's happening. Okay, that is very, very important because these types of problems are not testing your coding ability. They're testing your ability to solve a tricky problem like this and come up with a reasonable solution by using a bunch of variables. Again, even my space complexity here is order of 1 because I literally have just a constant number of variables that I'm using, right? Again, this is a very, very interesting, very, very popular algorithm. And I've seen, again, from my own experience, I've seen some people who remember this by heart, literally. This is such a popular interview question at top-notch product-based companies. People remember the solution by heart. So to validate whether they're thinking clearly or not, I ask them this question. I ask them, the solution that you've written, prove that it is correct. Okay, I've seen some interviewers, some interviewee candidates who just remember this by heart. They don't understand the problem in depth. They just remember the solution by heart. Then I tell them, argue with an example that the solution that you've designed is correct. And if they don't think clearly, they'll get caught. Okay, if they remember things by heart, you'll get caught. The problem solving approach is important. And that's what you'll improve by actually tackling these harder problems and by tackling them using an example. Even when I had to solve this problem, when I was writing notes for this video, I actually took this example and actually solved it on a notebook. And that's how you obtain intuition, especially for problems like these.